We've done a lot of practice going from formulas to names, but you also need to be able to go the other way around. If you see a written name, you need to be able to see what that formula would look like. And while it's applying the same rules but in reverse, I wanted to show a couple of examples just to make sure that you feel confident with it. And I'm going to take all of these examples from your book, but I'm not going to do all the ones with answers in the back. I'm just going to do a few. So if you want to do more, it's a great place to practice. So let's look at 17a. And I'm telling you where this comes from because if you want more practice like this, then you can go do 17b, c, and d. This is from the back of the book, the exercises at the back of the chapter that start on page 1045. So 17a, the name is 2-methyl-propane. First, you have to look at the ending of the last word. A-N-E, ane, means it is a saturated hydrocarbon chain, all single bonds. And prop tells you it is 3 carbons in that saturated chain. The beginning part tells you that off of the second carbon is a methyl group. So that is our 2-methyl-propane. Let's look at 27b. 2,4-heptadiene. Now this ene at the end tells us there's a double bond. And this di tells us that there's 2 double bonds. It's a chain of 7. So 1, 2, 3, 4, 5, 6, 7. It doesn't matter which end you make be 1, as long as you're consistent. I generally always put the furthest left-hand carbon 1 when I'm drawing structures from a name. So this tells you that the double bonds are after carbon 2 and carbon 4. So 1, 2, 3, 4. So that's 2,4-heptadiene. 1-phenyl-2-butene. So ENE tells you that there's a double bond. Butene tells you that there are 4 carbons. 1, 2, 3, 4. That tells you that the double bond is after the second carbon. This tells you that off the first carbon is the phenyl group. And hopefully you remember that that is what we call benzene when it's a functional group. So this is our 1-phenyl-2-butene. Now remember, if it has a Y here instead of an E, that tells you it's a triple bond. I'm not doing an example like that, but just to remind you. What about 43A, where we have cis 2-hexene? Because we have not done any of these cis-trans ones. Ene means that there's a double bond. Hex means that there's a chain of 6. But before we draw this out, remember that we have to draw it with the stair-step look so that we can show cis or trans. So 1, 2, the double bond is after the second carbon, so 3, it's cis. That means that they are on the same side, so it should go up. 4, 5, 6. If it said trans, this carbon would have gone here, right? So make sure you can unpack names even when they include cis and trans. Let's look at some functional groups. Let's look at these. And these are all out of your book from page 1048. The first thing to do is to decide what the main functional group is. OL tells us that this is an alcohol, and it tells us that it's a chain of 4 single bonded carbons. So let's draw that. 1, 2, 3, 4. The alcohol is off of carbon 1. This tells us that off of carbon 2 is a methyl group. So if you unpack them step by step, you'll be able to go the other direction. And it's good practice because if you can recognize this, then you clearly know the naming rules. Let's look at these last two. Al, not to be confused with Ol, tells us that we have an aldehyde. Because aldehydes always have to be on the end, you know that the aldehyde is at the end of a 4-carbon chain. All single bonds. 1, 2, 3, 4. And there's our oxygen. We also, because this is carbon 1 always, can see that off of carbon 3, we have a halide, chlorine. The last example on this slide, because it ends in ONE, we know it's a ketone. And because it says hexa, we know it's 6 single bonded carbons. 1, 2, 3, 4, 5, 6. We know that the ketone is on carbon 2. We also know that on carbon 5 there are 2 methyls. So 1, 2, 3, 4, 5. So this is 5,5-dimethyl-2-hexanone. Because this involves further branches over here, we wouldn't use our common naming for this. We wouldn't. So this would be the only name we would have for this one. Let's look at these last 3 examples. O8 tells us that we're dealing with an ester. And benzoate tells us that we're dealing with an ester that was derived from benzoic acid. So the main chain here is a benzene ring. So we do 1, 2, 3, 4, 5, 6. Draw our circle here. Doesn't matter where we come off of it. And here's our carbon that is part of our carboxyl group. So we have that and this one. And then this tells us that the alcohol was methanol. So there'll be just 1 carbon here. (38D). This one's got a pretty easy identifying factor here. It says acid, so we know it's a carboxylic acid. We also see the OIC. But you can also tell there are a lot of other functional groups and branches going on here. We know that these numbers do not tell us anything about where the carboxyl group is, because in a carboxylic acid, the carboxyl group has to be on acid 1. Hexane tells us that we have 6 carbons, single bonded together. 1, 2, 3, 4, 5, 6. And number 1 has the carboxyl on it. This tells us that off of 2 and 4 we have methyls. So 1, 2, 3, 4. It doesn't matter if you go up or down. And this tells us that off of the 3rd carbon we have a chlorine. 1, 2, 3. So it's like a roadmap that will get you to the formula. Because there wasn't a good example in your book, I just made up one here. For our final one, we need to do an amine. This one is propylaminopentane. And I use the IUPAC name here instead of the common one, but we'll talk about both. So this amino tells you there's a nitrogen. And on one side, pentane, there are 5 carbons. 1, 2, 3, 4, 5. On the other side, there are 3 carbons. 1, 2, 3. If we were going to name this using the common naming, we would just say pentyl propyl amine. I would accept either. I think that both make sense, but you should be able to recognize either as well. So hopefully now you can feel confident going both directions on this, from a formula to a name, from a name to a formula. You need to be able to produce a name and to unpack a name to produce a formula.